Okay, part 8, how to insert your data from Excel to the Word document. So the documents that you need is first the template of stage 2, okay, and then Excel. So it means the data that you have already calculated until the graph that you have already produced. Next, the blank page, just in case if you want to transfer the table from the Excel and then to the Word, we need to copy paste as a picture. Okay, so go back to the template. So this is the rubric. There are two things that you need to do in this stage: data and graph analyze the data and graph, and the data interpretation. I put also sample. So this template, if you want to pick the long instruction, so you will get the sample, but if you pick the short, so you don't have the sample. So the first picture that we need to insert is raw data table. So you can go to the Excel, go to the step number 1, go to the second step. Okay, and then did you see the first table? You can just directly copy paste, copy, and then after that go to the new document, and then you need to paste as a picture. Now don't forget that, did you see, you need to paste as a picture, this one. Now after that you need to make behind the text, so it's easy for us to move. So copy and then put it in the picture or data table, and then we can make it a little bit bigger. Okay, the next one is sample calculation. Remember, there are 4 calculation. Just go to step number 4. There are 4 calculation that I need to see. The average, how do you calculate the average of volume and AOH? Okay, just put one sample. Yeah, I need you to put the formula and then example. How do you find the concentration of vitamin C? Okay, you don't need to use this one, just delete. But the one that you are going to determine to find the way that you want to use to determine the concentration of vitamin C, you need to use the formula X1 M1 V1 equals X2 V2 M2 V2, and then you can put the sample. How to find the absolute uncertainty of your IDV, and how to calculate the relative uncertainty of your concentration of vitamin C. Okay, and like I have already explained before, the tools that we are going to use, not the Erlenmeyer, but we are going to use the Burat, and also you need to use the measurement cylinder. Okay, and then after that find the total percentage, and you can find the relative uncertainty of the concentration of vitamin C. Okay, we need to put vitamin C. Okay, and then space. Okay, and after that you can copy all the calculation, go to the Word document and then put it here. If you see it's in bold, so please make sure do not bold it. Then erase this one. Maybe we can put in. Okay. Okay, you make it complete. Okay. The next one is you need to insert the process data table. Okay, so this is the process data table. So you can go to Excel, go to step number 2, and then this is the second one. This is the first process data table. So you just copy, okay, and then go to the new document again, and then paste as a picture. Okay, don't forget you need to make a behind the text, copy, and then you just insert in this part. hard. Now, if the table it's a little bit bigger, you can make it small like this. Okay, or you can make it bigger also, the column like this. Next, we go to the second processed data table. So go back to the Excel and copy paste the third one. Now, there are two options for the second processed data. This is the first one. Remember, you need to paste as a picture and then behind the text. The second one, you can use the table in step number 3. It's more simpler. Okay, it's simpler than the previous one. Okay, so it depends on you. If you want to put the detail, so you can pick the first one. Okay, but if you don't want to put the details, so you just pick the second one. For me, I love the detail one, so I prefer to use the first one. And then copy paste in here. Just make sure the size of the table are similar, it'll be better. And then after that we can make it bigger. Just put the picture of the graph into in the next page. Oops. Okay, now this is the picture of the graph. Now for the graph, it's very easy. You just copy paste directly. You don't need to paste as a picture. So just paste Ctrl V. That's it. Okay, but don't forget you need to make behind the text so it's easy for us to move it. Okay, we can make it a little bit smaller. Okay. Okay, and the next one is the result quantitative. We can make it bigger a little bit this way. So hard. Okay. Now for result qualitative, you can go back to the step number 1, and then there are two pictures before and after titration. So this is from the colorless to the pale pink. Now you need to copy the picture. Now for result qualitative consists of the picture of your observation. Okay, I have already provided the picture, so you just copy paste, and then after that you need to explain. Okay, describe what did you see. Yeah, later in the experiment, if you can smell something, if you can see the bubbles, if you can hear something, so it will be better you put. So using 5 senses, but in this time you just explain about or describe about the color changing, okay, before and after titration. Okay, so that's the first task. Okay, we have already got the data calculation in here. Right now we go to the data interpretation. So there are two paragraphs that you need to make it. Okay, so the first paragraph talking about the pattern of correlation, either positive or negative. Now you can take a look in the sample. Okay, did you see the yellow one? The yellow one talking about negative correlation. As can be seen, the graph has a negative correlation. Why? Because if you see the graph, the trend line itu go down. It means your IDV increased but your DV decreased. Nah, you need to take a look your graph and then try to interpret whether it is positive or negative correlation. Okay, and after that you can explain in the first paragraph. Now, the next one is significant trend. The significant trend, it means you need to mention the value. Okay, in this part, the student mentioned the value. For example, the student picked the first variation, third, and fifth, only 3 variation. So the student not explain but mention. So the first variation, when the student used 5 milliliter hydrochloric acid, the concentration itu becomes around 10 until 12 mole decimeter to the power of minus 3. So You don't need to pick all the variation, but you just mention the third one. Okay, not the third one, the three significant. It could be the first, the third, and also the last one. So when the when people read your interpretation and you said, oh, negative correlation, they can know, oh, because the significant trend like this, oh, this is the evidence. So you need to mention the value. Okay, that's the second part that you need to explain in the first paragraph. The second one, error bars. Now, error bars, how can I see the error bars? You can see from the, did you see there is a very straight line in here, vertical and horizontal, like a plus sign? That's the error bars. Okay, and then these error bars can we can categorize as a small, very small error. So that's why the students put in here small error for x-axis and small error for y-axis. What is small x and x-axis is the horizontal one. Remember, yeah, x-axis is the horizontal one, which is reverse to your IDV. Now you can mention by looking the absolute uncertainty of your IDV. That's the axis, the x-axis error bar. That's the horizontal one. But for the y-axis, that's the vertical one. Now, if you want to mention the value, you can see from the relative uncertainty of your vitamin C, your DV. That's, we call it the y-axis error bars. Pak, do we need to mention all the value? No. You just compare. Take a look, yeah. How can we say it is small, Bapak? Yeah, can you see the absolute, the error bar for x-axis, the independent? 0.5 and 5. Is it, if you compare 0.5 and 5, of course 0.5 is so small, right? It's only like 1/10. Okay, so that's why we can categorize is as the small, is a small error bars. Take a look, this one also 10.82 and then 1.09. That's the y error axis error bar. Well, it's 1/10. It's so small. Okay, how do we know it's big and small? By looking the value, or we can see from the graph. Okay, now that's the first paragraph. Okay, you need to complete the interpretation. Remember the pattern of the correlation. Okay, the significant trend, the sample, the value, and the error bars. Okay, in the second paragraph, you need to explain the R square. Now, you can see directly from your graph. I have already put the sample here. So this is the R square mentioned, and then you need to state it, because as R square, it will represent the reliability. So if your R square 0.99 close to 1, so your reliability of your data, good or not? Find the theory about it. Nah, ini the students put the theory. Oh, kalau very close to 1, so it means the reliability of your data is so good, so high, because according to blah 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 blah. Okay, that's the first thing that you can mention. The next one, quadratic equation. If you see there is a quadratic equation here, y equals blah 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 x minus blah blah blah. Now you need to explain what does it mean. Okay, that's your data interpretation. And the last one is you need to comment about anomaly data if you have. So based on your graph, you need to see whether suddenly it could be, it's supposed to be increased, and suddenly in the third variation it's decreased. Now that's anomaly. Or maybe your error bars is so big. That's also anomaly. Or it could be your trend line of your graph, okay, is just like a zigzag. So there's so many anomaly there. So that's why you need to take a look whether you have or not. If you don't have it, so do not force yourself to put the anomaly. Okay, I think that's all for the data interpretation and also how to calculate your data. Thank you.